Hello friends, welcome to my channel Heart of Civil Engineering. In today's lecture of Mechanics of Solid, we will solve the examples related to coplanar non-concurrent forces. So let us move through the first example. Find the magnitude, direction and perpendicular distance of resultant with respect to point O, means with respect to this point O, for a system shown in figure. So here the number of forces are more, hence we have to go for summation of all the horizontal forces, summation of all the vertical forces, so that we can easily find the value of resultant. So first of all we will go for sigma h, summation of all the horizontal forces. So our first horizontal force is over here 10, and as we know that plus, minus, plus and minus, and this 10 Newton is going over positive x-axis, so it will be plus. Then our second force is 5 kilonewton, and this 5 kilonewton force is going towards minus x-axis, hence it will be minus 5. And our next force is 20 kilonewton is inclined and making an angle of 45 degree with the horizontal x-axis. So our one component will be 20 cos 45 and our second component will be 20 sine 45 degree. So this 20 cos 45 will be our third horizontal force, and this horizontal force is moving towards negative x-axis. So here I will write as minus 20 cos 45 degree. So after calculating this, you will get the value of sigma h as minus 9.14 kilonewton. Now we will go for summation of all the vertical forces. So our first vertical force is 20 sine 45 in upward direction, and hence it will be positive. So 20 sine 45 degree, and our second vertical force is 20 kilonewton. It is also going towards plus y axis, and hence it will be positive. So I will write over here as plus 20, which will be equals to 34.14 kilonewton. As the value of sigma h and sigma v are known to us, then hence we may easily calculate the value of resultant capital R equals to under root of sigma h square plus sigma v square. So the value of sigma h is minus 9.14 square, and value of sigma v is 34.14 square. So here we will get the value of resultant as 35.34 kilonewton. Now, as we had find the value of resultant force, now we will find the direction. So for direction we know that tan theta equals to sigma v by sigma h. The value of sigma v is 34.14 and value of sigma h is minus 9.14. So here we will get the value of tan theta as minus 3.735. Therefore, your theta will be equals to 75 degree. Here, since the value of sigma h is negative and value of sigma v is positive, therefore our resultant, that is capital R, will be in second quadrant, as we had discussed in the previous lecture also. Here, your sigma h, that is horizontal force, is negative and sigma v is positive. Hence, our resultant will lie in second quadrant. So, here the magnitude and direction of resultant is calculated. Now, we have to go for perpendicular distance. So, to find the position of resultant with respect to O, we have to first consider some value. So, first of all, let resultant capital R be at a perpendicular distance x from O. Means we had, as we know that our resultant is in second quadrant, hence I have to show our resultant in second quadrant, and this resultant be at a perpendicular distance x from O. We have to denote this sentence in the figure also. Now we will go for moment, as we have to find the perpendicular distance of resultant with respect to point O. Hence, we have to take the moment at point O. So, taking moment about O. So, our first force will be R, that is resultant into perpendicular distance x, and this Rx will move towards point O in anti-clockwise direction, hence it will be negative. So I will write over here minus sign equals to. Now let us go for first force. So let us take this 20 kilonewton force. So this force makes the perpendicular distance 2 meter with respect to point O. So, and this force will move towards point O in anti-clockwise direction, that is in minus. So I will write over here minus 20 force into perpendicular distance as 2. Now we will go for another force, as 20 kilonewton is making an angle 45 degree with respect to x-axis. So our one component will be over here and the second component will be over here, as this 20 cos 45 and this will be your 20 sine 45. This 20 sine 45 is having the same line of action as point O. Hence, this case will be neglected. So, I will go for 20 cos 45. So, 20 cos 45 degree. This 20 cos 45 makes the perpendicular distance of 2 meter with respect to point O. So I will write here 20 cos 45 into 2. And this 20 cos 45 will move towards point O in anti-clockwise direction. So this will be your minus. Similarly, this 10 kilonewton force is also having the same line of action from point O. Hence, this will be also deducted or neglected. So here, after putting the value of capital R that we had obtained earlier, as value of capital R is 35.34. So I will write here minus 35.34 into x. The value of x is unknown for us. So here minus 40 minus 28.28. After solving the above equation, we will get the value of x as 1.932 meter from point O. So this way you have to find the magnitude, direction and the perpendicular distance x of the resultant force with respect to the given point. Now let us go for another example. Here in the second example, it is given that we have to find the magnitude, direction and the perpendicular distance with respect to point A for the system shown in figure. So here also 500 Newton force is making an angle 45 degree with the vertical axis. So we will consider this 45 degree over here with reference to horizontal x-axis. So our first force will be 500 cos 45 degree and our second force will be 500 sine 45 degree. Remember one thing, we had considered 45 degree that is making with respect to horizontal axis only. Here also 800 making an angle 30 degree with the horizontal only. So here 800 cos 30 degree and the second component will be 800 sine 30 degree. So let us go for summation of horizontal forces and summation of vertical forces. So summation of all the horizontal forces will be equals to first 1000 Newton, which is going towards positive x-axis. So it will be plus 1000. Now second 500 cos 45 degree, it is also going towards positive x-axis. So here plus 500 cos 45 degree. 800 cos 30, it is going towards minus x-axis. Just remember this figure for considering the value of positive and negative. So here minus 800 cos 30 degree. After solving this, you will get the value of sigma h as 660.73 Newton. Positive, so I will denote over this notation. Now we will go for vertical forces. So summation of all the vertical forces. So first of all, this force 850 Newton and it is going towards positive y-axis, hence it will be positive. Then 500 sine 45, it is going downward direction, hence it will be negative. So minus 500 sine 45 degree. And this 800 sine 30 degree is going upward. So plus 800 sine 30 degree. So after solving this, you will get the value of sigma v as 896.45 Newton. It is positive, hence I will denote by this notation. Now we will go for the equation capital R equals to under root of sigma h square plus sigma v square. Value of sigma h as 660.73 and value of sigma v as 896. So we will get the value of capital R as 1113.63 Newton. Now we know that tan theta equals to sigma v by sigma h. So putting the value of sigma v and sigma h as we had obtained earlier. So here we will get the value of tan theta as 1.356 and value of theta will be equals to 53.59 degree. Here the value of sigma h is positive and sigma v is also positive. Hence our resultant will lies in first quadrant. So here the value of sigma h is positive and value of sigma v is also positive. Therefore, our resultant will lies in first quadrant. So now let us go for the perpendicular distance. So in the previous example, we had considered that let capital R, that is our resultant, this resultant is at a perpendicular distance, x from point A, as we had to find the perpendicular distance with respect to point A, and our resultant lies in first quadrant. Hence in first quadrant our resultant will go in this direction. So I am denoting over here. Now we had considered R as the resultant force making an angle x, sorry, perpendicular distance x from A. So R into x, this R will move towards point A in clockwise direction, hence it will be positive, equals to, now we will go for first force. So our first force is 400 Newton into meter. Moment is given and this moment is going towards point A in clockwise direction. So it will be plus 400. Then our second force is 800 sine 30. This force move towards point A in clockwise direction, hence it will be positive, and this 800 sine 30 makes the perpendicular distance with respect to point A as 1.8 meter. So I will write over here plus 800 sine 30 into 1.8. Now this 850 Newton will move towards point A in clockwise direction, hence this will be positive. So plus 850, and this 850 makes the perpendicular distance of 1.8 meter with respect to point A. So here 1.8. Now as 500 cos 45 lies on the same line of action from where we are considering the moment, so this 500 cos 45 will be neglected. Now we will go for 500 sin 45. As this 500 sin 45 move towards point A in clockwise direction, so I will write over here plus 500 sine 45 degree into, this makes the perpendicular distance of 1.4 meter with respect to point A. So here into 1.4, and the value of capital R we had obtained in the previous step as 1113.63. So after solving this equation, you will get the value of x as 2.82 meter from point A. So by this way, the value of resultant force with respect to A point has been calculated. Now we will go for another example. So in this case also we have to find the magnitude, direction and perpendicular distance of the resultant force with respect to O point, means with respect to O point. So first of all, we will go for the forces. So this 80 Newton force is making an angle 60 degree with the vertical axis. So we will consider this as 30 degree as the total is 90 degree. So your first component will be 80 cos 30 degree and your second component will be 80 sine 30 degree. Here 140 Newton into moment, Newton into meter, moment is given in anti-clockwise direction. This 50 Newton force and here 60 Newton makes an angle 45 degree with the vertical axis. Hence, with the horizontal axis, it will make 45. So it has two components, 60 cos 45 and here 60 sine 45 degree, and this 40 Newton towards horizontal axis. So let us go for summation of horizontal forces and summation of vertical forces. So first of all, sigma h. So our first force, let us consider this 40 Newton as first force. So sigma h is 40 and this force is going towards positive x-axis. Hence, it will be considered as positive. So plus 40. Then our second is this force 80 cos 30. It is also going towards positive x-axis. So plus 80 cos 30 degree. Then our third force is 60 cos 45, but it is going towards negative x-axis. So I will consider over here minus 60 cos 45 degree. So after solving this, you will get the value as 66.86 Newton positive. Hence, I will denote over positive axis. Now we will go for vertical forces. So sigma V equals to your first vertical force is over here 50 and it is going upward. Hence, it will be positive. Then next is your 80 sine 30. It is also going upwards, hence it will be positive plus 80 sine 30 degree. Now third force is 60 sine 45. It is going upward, hence it will be positive 60 sine 45 degree. So after solving, you will get the value as 132.82 Newton positive, therefore upward direction. Now we will go for the equation capital R equals to under root of sigma h square plus sigma v square. So after putting the value of sigma h as 66.86 and sigma v as 132.82, you will get the value of capital R as 148.34 Newton. Now let us go for the direction. As we know that tan theta equals to sigma v by sigma h. Value of sigma v as 132.82 and value of sigma h as 66.86. You will get tan theta as 1.98 and therefore theta equals to tan inverse of 1.98, which will be equals to 63.20 degree. Here sigma h is positive and sigma v is also positive. So I will write over here sigma h 66 is positive and sigma v 132 is also positive. Hence our resultant will lies in first quadrant. So now let us find the value of perpendicular distance. As we know that the resultant is in first quadrant, so let us consider, let R be at a perpendicular distance x from O. This is your capital R and this capital R is at a perpendicular distance x from point O. So first of all, R into x. Here R into x, this R will move towards point O in clockwise direction, hence it will be positive. Then It has two components, 80 cos 30 and here 80 sin 30. So equals to 80 cos 30 into this 80 cos 30 makes the perpendicular distance over here with respect to point O as 1. So 80 cos 30 into 1 and it will move towards point O in clockwise direction, hence it will be positive. Next, 80 sin 30. This 80 sin 30 makes the perpendicular distance over here and with respect to point O, your total distance will be 7. So into 7 and this 80 will move towards point O in anticlockwise direction, hence it will be negative. Next, 140 Newton into meter moment is given in anti-clockwise direction, hence this will be your minus 140. Then 50. This 50 Newton force will move in anti-clockwise direction, hence it will be minus. So minus 50 into this makes a perpendicular distance from point over here. So this will be 1 and 2. So distance will be 2 meter. Then 60 Newton has two components, 60 sin 45 and 60 cos 45. This 60 sin 45 is on the same line of action, hence this will be neglected and we will consider 60 cos 45 in anti-clockwise direction towards point O. So minus 60 cos 45 into perpendicular distance over here from point O, that is 5. So 5 and this 40 Newton making perpendicular distance over here with respect to point O as 1 and this will move towards point A in clockwise direction. So plus 40 into 1 and we had obtained the value of resultant as 148.34 in the previous slide, and after solving the above equation you will get the value of x as 4.198 meter from point O. So by this way you have to find the magnitude, direction and the perpendicular distance with respect to O for the system shown in figure. In the first step, you have to find this value of sigma h, sigma v, then go for resultant, then find the magnitude, then find the direction, that is theta, and after getting the value of all the above, go for the perpendicular distance, that is x. Thank you. In the next lecture, we will go for the more example related